Hello, Mr. Saloger, back with part two of the relative time lesson. Why a part two? Because Screencastify only gives you 5 minutes for your lesson, so here comes part two. I want to come back to this lesson diagram on the law of cross-cutting relationships to review a couple big ideas and show you something also important that you need to know, not mentioned in part one. So first, to interpret this diagram, we're going to use the law of superposition. Since the oldest rocks are on the bottom, we have two things on the bottom, sandstone and igneous rock. We know that the sandstone had to come first because the igneous rock is cross-cutting the sandstone. So the order of events here would be sandstone, followed by the shale, the unconformity, the limestone, and then finally the igneous intrusion. So now here's the part we didn't talk about in part one that is super important. You need to be able to determine that along the boundary here where we have limestone in contact with the magma that formed this igneous rock, if you use page 7 of your reference table, you'll be able to see metamorphism of limestone or dolostone makes marble. So we would anticipate that marble would be in this location. Now in this spot down here, we have sandstone in contact with igneous rock. We have to remember that before it was igneous rock, it was liquid hot magma. The heat from that magma penetrated into the rock, and metamorphism of a quartz sandstone will make a quartzite. Our next diagram, this is where we left off in part one. What we want to focus on is we have a fault and an intrusion. And the most common question is, which came first? And in this case, we should be able to tell that the intrusion had to be there before the fault because it wouldn't form with one piece over here not connected to this piece. That fault is cross-cutting and displacing the intrusion. So therefore, it had to be shale, limestone, then we've got our sandstone, we have an intrusion going up and through, and we have a fault that is breaking those sedimentary rock layers. We have an unconformity followed by a siltstone coming very last. Take a look at a couple more diagrams. In this one, we have some horizontal layers, we have an igneous layer, we've got an unconformity. So here's how we would interpret this one. We have igneous rock basalt in the bottom as indicated by our symbol. We have a sandstone on the bottom. We know this sandstone had to come first because the igneous rock is cross-cutting the sandstone. So it goes sandstone, shale, then the intrusion, then our unconformity. We know the intrusion comes before the limestone because we have to remember that this would have been magma, which is really hot. And if that limestone was already there, we would see evidence for contact metamorphism between the magma that formed this igneous rock and the limestone that is above. So then comes our limestone, and the very last thing is our shale due to the law of superposition. Take a look at another diagram. We have a couple of intrusions. We see that one intrusion only goes up to the unconformity. That is the diorite. We see the gabbro goes all the way up through everything to the top. So the order of events here would have to be sandstone, siltstone, intrusion of diorite, unconformity, deposition of limestone, followed by the gabbro coming last. And that's from the law of cross-cutting relationships. Remember that along the limestone and the igneous rock, you'd have marble. Where the sandstone comes in contact with these igneous rocks, you'd likely have quartzite. Here's another example where we have two cross-cuts of igneous rock, and we can see that one is cross-cutting the other. We have a granite represented by the pluses and a gabbro with the equal signs. The way we would interpret this is we would have the shale, followed by the limestone. Next comes our siltstone. Then we have our granite intrusion, followed by our gabbro intrusion, which cross-cuts the granite. We have a period of erosion, which is our unconformity, and then our siltstone on top. This concludes part two of our relative time lesson. I hope this helps you to interpret geologic cross-sections in your earth science class.